are. The Falk Corporation has a 7% coupon bond outstanding. The U Corporation has an 11% bond outstanding. Both bonds have 12 years to maturity and make semi-annual payments. The yield, which is the current market rate, is 9%. What if interest rates fall? What is the change in the price of the bonds? What if they rise? And then what does the problem tell you about interest rate risk of lower coupon bonds? Okay, so let's just do what we did before. Falk, let's do the coupon rate. I'm going to put the face value up here, and since I have done this multiple times tonight and I picked a different face value, I'm going to pick $10,000. So if this is a $10,000 bond, what happens? So Falk is one company and U is another. The coupon rate is 0.07 for Falk. The other one is 0.11. We can put this in percentage terms if we like. They both have years of 12. They make semi-annual payments. Hold on. Let's insert and let's do the coupon payment. So the coupon rate is going to be 7% divided by 2. And then we're going to multiply that times the face value of the bond, but that's not a, there we go. All right, so the coupon payment when it's 7% is $350 out of a $10,000 bond because we did 7% divided by 2. And again, those are semi-annual coupon payments. Same thing here, it's 11% divided by 2, which is 5.5 times $10,000. And then the number of periods is going to be the years times 2 because it's semi-annual. Okay, so we have, and let's forget the coupon rate for a second because we don't really need it anymore. Let me white that out too. Okay, so our next step is to think about what is the price. And the reason that, that I'm saying this is because we have everything else that we need. In fact, let me black out the years as well, or white out the years. So we have the coupon payment, we have the number of periods, we have the face value. The only thing, oh, and we currently have the yield to maturity of 9%. Oops. So that means the effective semi-annual rate is that divided by 2. And technically speaking, I don't have to do this in both columns. I just think it's easier to do the formulas that way. Okay, so we have all that. What's the price? And again, we don't need this anymore because we already transformed it into a semi-annual rate. So we can do PV. The rate is that. The payment is that. I'm sorry. The number of periods is this. The payment is that. Future value is that. Okay, so this is a 9% yield to maturity. I'm going to make that bold. All right, if interest rates suddenly rise by 2%, what is the price change in these bonds? So let's just come down here and do 11% yield to maturity. So rather than type it in and have to black it out, I'm just going to do 11% divided by 2. That is 5.5%. That makes sense. Notice that this is an 11% bond. I'm just going to bold that for a second. The yield to maturity here is 11%. So I'm going to go ahead and make a prediction that the number that we get for the price is going to be equal to $10,000. Number of period, oops, I'm sorry. The rate is this, the number of periods is that, the payment is $350. The future value is 10,000. Close that. And lo and behold, it is $10,000. So remember when we said you make a bond and it comes out on the first day and the interest rate is 11%. Well, that's the only time it'll trade at par. And then the interest rate is going to move around and move around and move around. If it hits 11% again, it will trade at par, which is $10,000 because that's the face value of the bond. This interest rate is not par. 11% is higher than the original coupon rate of 7%, and therefore it's going to trade at a discount. Now the next question is, what if they fall by 2%? So let's just make a prediction here. This is a 7% coupon bond. Rates are going to rock along. When it hits 7% again, it will trade at par. So effective semi-annual rate is going to be 0.07 divided by 2. Oops. Equals 0.07 divided by 2. And let's do the price. Equals PV. The rate is that. Number of periods is still 24. Payment is $350. The future value is $10,000. Oh, and lo and behold, the price when you're trading at 7% is exactly par. And so the question is, what's the percent change in price? Technically speaking, that should be a negative, so let's add it to the end. And let me just lock this cell so I don't have to deal with that again. Okay, that should be right. All right, so the price goes down by 13% when the interest rate bops up by 2%. The price here goes down by 12%. Notice that this is a lower coupon bond. When the price changes by 2%, the price, this price is going to change more. This price that was 11%, let me unbold that, is going to change less. Over here, a 7% coupon bond, a 2% change in price moves it up by 16.9%, and this by only 15.3%. So the lower coupon bond is much more sensitive to changes in interest rate. And that's essentially what this project is, or what this question is asking you. So yeah, we got the right number, 17% and 15.4. So again, let me just go over the logic. We started the market rate is 9%, and we have these two prices. The market rate jumps up to 11% overnight. The cash flows are still the same, but this bond that was trading at, or that originally had a coupon payment of 11%, again trades at par. This one has to trade at a discount because the interest rate went up. Well, actually, they both trade at a discount relative to this price, but the price went down more for the 7% bond. This would be a very logical theory question to ask on a test. When the interest rate goes down, this bond, which was originally a 7% coupon rate, trades at par again, and the price goes up by more than it did for the 11% bond. So the lesson here is that the lower coupon bond is more sensitive to movements in interest rate, and that when the coupon rate is equal to the market rate, that you will trade at par.